नहीं नहीं, अभी ये तो वो है, ऑर्गेनिक केमिस्ट्री का नया टॉपिक होगा, ठीक है। रीडॉक्स हमने कवर करना था लास्ट पार्ट, ठीक है, सो वी डूइंग दैट। तो रीडॉक्स के अंदर ना विल स्टार्ट ऑफ विद कि where we left off, I told you कि अच्छा, we did the old stuff कि primary alcohols getting oxidized to aldehydes getting oxidized to carboxylic acid. This is what we did last time. Or I told you वो K2Cr2O7. This is you already familiar with this K2Cr2O7 KMNO4. Aldehyde to carboxylic acid, you have toluenes and phelings as well that can do that. Aldehyde पे अगर रुकना है तो what you do is कि you, instead of using reflux, you start distillation so that the aldehyde immediately evaporates when it is formed, ठीक है। अच्छा, फिर ये था कि this was new कि you have to remember that only two of the carboxylic acids they actually get oxidized, ठीक है, only two of them. One of them is methanoic acid and the other one is ethane dioic acid, oxalic acid. तो ये A2 का था, and they're the ones that get oxidized. What we can do is we can do a couple of questions about this. Okay, let's say I've got Purana hoga, ठीक है, about so I'll just give you an example about oxidation of alcohols. So for example, I've got a molecule and so that molecule has there's a cyclic ring, let's say, and maybe there's this chain up here. What else is there in this molecule? You will have, let's say, you've got an OH group, ठीक है, over here. So यहाँ पे you've got an OH group, and you've got another OH group, let's say, over here, and there's one OH group that's right at the end. ठीक है, so let's say this is the molecule and I want to oxidize it, and I heat it with concentrated, not concentrated, acidified KMNO4 and reflux, acidified K2Cr2O7. And I reflux. So पहला काम है, you have to identify which one is a primary, which one is a secondary, which one is a tertiary alcohol. So starting with the first one, ये वाला, what is this alcohol? ये वाला कौन सा? This one. Primary, secondary or tertiary क्या है ये? Anyone, any idea?
So secondary होगा.
Secondary, ठीक है, because you have to look at the carbon chain, and the carbon is bonded to two carbon chains, ठीक है, so that's a secondary alcohol. अच्छा, what about this which जो यहाँ पे है? ये क्या होगा? ठीक है, that one is it, ठीक है, so that's a tertiary alcohol, because if you look at the carbon over here, so that's bonded to three carbon chains, so that's a tertiary alcohol. Oh, finally, you've got this OH right at the end. What is this one? ठीक है, that one is going to be a primary alcohol, ठीक है. Reason it's a primary alcohol is because this carbon is bonded to just one carbon chain, so this one over here it's a primary. So this one is a primary alcohol, ठीक है. So first thing is you have to identify which is which, and once you're done with it, तो फिर ये करना पड़ेगा कि you would and what I'll do is I'll just copy the molecule and I'll change all of them, ठीक है. What happens is इसके अंदर रिमेंबर दिस के अच्छा एक चीज सॉरी हमने यहाँ पे मिस कर दिया, वी जंप्ड फॉरवर्ड, ठीक है, वो हमने we didn't do it for secondary alcohol. इसको थोड़ा सा नीचे कर लेते हैं, let me just add, अच्छा let me इधर ऊपर ना, let me just add about अच्छा let me just add about secondary alcohols, ठीक है, we didn't do that, तो वो complete नहीं हुआ था कि what happens to secondary alcohols, they turn into ketones, ठीक है, that was AS as well, secondary alcohols they turn into, अच्छा they're going to turn into ketones. Also ketones में convert करने के लिए you need the same reagent that you had over here, ठीक है, वही exact same reagents, and this was obviously oxidation as well. और इसमें ये कि you have the same exact reagents. This is what a tertiary alcohol is. It's got an OH group and it's going to have 2 carbon chains that are attached to that particular carbon atom, and this carbon atom will turn into a ketone. The molecule remains the same, only the carbon atom then eventually turns into a ketone. That's it. So that's what, and tertiary alcohols don't get oxidized. Okay, so तीसरा जो था ना, that is tertiary alcohols, they undergo no oxidation whatsoever.
सर
हाँ जी,
सर तो उसकी ये वजह थी कि मतलब कार्बन टू कार्बन बॉन्ड तोड़ना काफी मुश्किल हो जाता है ना, ये वजह थी या
स्टेबल
कोई
हो
और
सा
चीज?
ये वजह थी.
अच्छा अच्छा।
अच्छा this one no oxidation. तो ये total था, ठीक है, that was first one primary alcohols, then you had secondary, and then you had tertiary alcohols. So अब we're doing the example, ठीक है. So this is still AS apart from the oxidation of carboxylic acids, ठीक है, you didn't do that in AS. So what's going to happen to it? Secondary alcohol will turn into a ketone. This one over here, this one will turn into a ketone. So khali is part ko na, what you're going to do is, I mean, the secondary alcohol will just turn into a ketone. So यहाँ पे, and I've got an O. ठीक है, that turns into a ketone. Tertiary alcohol, nothing happens to it. ठीक है, so this one remains as it is. What happens to a primary alcohol? A primary alcohol will turn into a carboxylic acid eventually. So इसका ना ये सारा सब कुछ change हो जाएगा, and it will eventually turn into a carboxylic acid. It will become double bond O and OH. ठीक है, so there's going to be OH and double bond O, so that will turn into a, so that will turn into a carboxylic acid. This turns into a ketone. और फिर ये वाला जो है ना, this alcohol, no change happens to it. ठीक है, so that's this question, and bas one question would be enough, ठीक है. So you've done this in AS. ठीक है, is this clear?
यस सर।
और फिर एक इसका ना exact नहीं, in structures you can't even name them. I mean, cyclic structures nomenclature does not really apply to cyclic structures. I mean, it's a lot harder to actually name cyclic structures, ठीक है. अच्छा फिर the opposite of all of this, there was reduction as well, ठीक है, that was the exact opposite of all of this. तो इसी का एग्जैक्ट रिवर्स रिडक्शन. Now in reduction, what would happen is that that a carboxylic acid will turn back into, so that will turn back into an aldehyde, and then it will turn back into a primary alcohol. So it turns back into a primary alcohol. As similarly, you have ketones, and you reduce a ketone, it turns back into a, as it's going to turn back into a secondary alcohol. And that's it. Tertiary alcohols never got oxidized in the first place. So how do you reduce a carboxylic acid? So carboxylic acid ke liye you need a powerful reducing agent. Carboxylic acids don't get reduced very easily, so for that it's a powerful reducing agent, and that's LiAlH4 only. ठीक है, इसको कहते हैं lithium hydridoaluminate. Or I mean, there's several names for this. अच्छा, so lithium hydridoaluminate. And aldehydes can also be reduced back to a primary alcohol. For that, you can use two reagents. One of them is LiLH4, or इसके अंदर ना you can also use NaBH4, sodium borohydride hydride. और इसके अंदर भी ना दो होंगे LiLH4. ठीक है, these were your two primary reducing agents. Or NaBH4. ठीक है, so you had these two primary reducing agents. So लेकिन first वाले में याद रखना, there's only one reagent that's going to be used in the first reduction. Okay, so this is exactly the opposite of what we just did earlier. Okay, this is exactly the opposite of oxidation. इसको मैं अच्छा, तो वो exactly opposite है उसका. ठीक है, is this part clear? That's also AS. ठीक है, is that clear?
Yes, sir.
Yes, sir.
अच्छा, फिर और हमने कौन सा किया था? A2 पे मूव करते हैं अभी. This was alkenes. We did the oxidation of arenes as well. ठीक है, that is done. The next one. Okay, there is nitrogen compounds का कर लेते हैं. अच्छा, so you've got, there's another thing called reduction of nitrobenzene. अच्छा, reduction of nitrobenzene is कि you've got a benzene with NO2 on it. अच्छा, ये हो गया, and there's going to be an NO2 that's going to be attached to it. अच्छा, इसकी reduction. what will happen in the reduction process is that you would need tin plus concentrated HCl. That's it. And this molecule will turn into, ये जो molecule है ना, that will just
सर ये
turn,
आपने 10 लिखा?
हाँ 10 है ऐसे, ठीक है. What will happen is कि वो the O will go away and it will become a phenylamine. So it becomes NH2. That's it. ठीक है. So this is your phenylamine. It's an amine with a benzene attached to it. You can remember this is an important reaction asked very frequently. So that's one, reduction of nitrobenzene. So similarly, you have another one which is reduction of amides. One second. It's 10 plus concentrated HCl. That's the reducing agent. Remember, when I'm talking about reduction, the reagent is a reducing agent by default. Okay? It's 10 plus concentrated HCl. अच्छा, फिर reduction of amides. Okay, उसके बाद what happens is, what is an amide? Amide is this thing that it looks like this. It's R, फिर C double bond O, and NH or N. ठीक है, like a peptide bond in biology. ठीक है, that's what an amide actually looks like. अच्छा, इसको अगर आप if you reduce this, हाँ जी,
सर इसमें NH2 होता है और वो CH Cr और फिर C डबल बॉन्ड, मतलब वो कार्बोक्सिलिक एसिड वहाँ पे होता है एंड में जाके COOH.
किसमें?
ये वो उसकी बात कर रहा था, ये अमाइड जो आपने पिछले पिछले जगह में लिखाया था सर, वो उस तरह से था.
नहीं, उसमें क्या था?
सर उसमें था वो पहले आपने NH2 बनाया था, फिर उसके बाद ऊपर CH था, नीचे R आ रहा था और फिर
वो
COOH था.
ये था ना, COOH तो नहीं होगा. एमाइड हमने सिर्फ यहाँ पे पढ़ा था लास्ट टाइम, ये बेसिसिटी के अंदर. आई टोल्ड यू कि इट्स नॉट बेसिक, दिस इज एमाइड. यही पढ़ा था ना
ओके सर.
हमने, और तो कहीं नहीं एमाइड पढ़ा.
सर वो एक्चुअली वो, हाँ सर सॉरी, एक्चुअली मैंने अमाइनो एसिड और अमाइड्स को कंफ्यूज किया था.
ठीक है, ये हमने वो एमाइड सिर्फ पढ़ा था, वो स्ट्रेंथ ऑफ बेसिस के कंपैरिजन में. दैट्स इट. ठीक है, दैट्स द ओनली प्लेस वेयर एमाइड शोड अप. ठीक है. अच्छा, एमाइड्स की रिडक्शन ऑफ एमाइड्स इज के दैट्स आल्सो LiLH4. वही आप यूज करते हो इसमें एमाइड्स के अंदर. जस्ट अ सेकंड. हाँ, ठीक है. सो you need a strong reducing agent for this. और इसके अंदर भी what happens is कि वो जो C नहीं है which had O in it, it now is going to have H with it. That's it. ठीक है, that's what's going to happen. कि और इसको हाईलाइट कर लेते हैं कि जो आपका वो था ना O, ठीक है, only this part changes. It has now actually become, it has now become CH2. So the oxygen is gone. I mean, one oxygen is gone and two hydrogens have been gained. So minus one oxygen and plus two each atom. So that is reduction. Okay, loss of oxygen, gain of hydrogen. Achha, then you have another reduction, which is another nitrogen compound. That's reduction of nitriles. Achha, reduction of nitriles is ke, you'll have nitrile क्या होता है? It's CN. ठीक है, RC and triple bond N. अच्छा इसमें क्या होता है कि when you reduce it तो H's get added to it, so it becomes R फिर C or N, लेकिन वो triple, it's like an addition reaction. You just have H atoms and H atoms added to the molecule, so it becomes an alkylamine. I said it becomes an alkylamine, or the conditions for this one is that you can hydrogenate it, so it's hydrogen plus nickel catalyst, or temperature jo hoga, that's going to be 150 degrees centigrade, or you can also use the reducing agent, which is LiAlH4. That can also be used. So bas ye, that's the reduction of 3 of your nitrogen compounds that you have to memorize. That's it. So that kind of sums up your oxidation and reduction reactions. मैं बस एक दफा देख लूं कि सारे कवर हो जाते हैं. We started off with just a quick summary. We started off with hydrogenation of benzene. That was reduction because double bond khatam ho gaya aur each hydrogens got added to it. Then you had oxidation of arenes. I told you that the carbon chain will simply vanish, and uski jagah pe na what you will get, uski jagah pe what you will get is you'll get lots of carboxylic acids, right, in that place. अच्छा फिर oxidation of alkenes, ये O levels है, so AS है, cold dilute, that's mild oxidation, and strong oxidation, double bond breaks, and you get 3 different scenarios with hot concentrated acidified KMnO4. The 3 scenarios are, depending on those 3 scenarios, what happens to the double bond, you get different products. Here we did primary alcohols turning into aldehydes, turning into carboxylic acids, and I told you that वो सारा तो पुराना AS था, but this is A2 that was added, that only 2 of the carboxylic acids, they actually get oxidized as well. One of them is methanoic acid, the other one is ethane dioic acid. And then
सर
हाँ जी,
सर वैसे लाइक आप चेक करें, लेकिन सर लाइक सिलेबस जो आपके पास सिलेबस है सर, उसके अकॉर्डिंग मतलब इसमें कुछ रहता है?
नहीं ऑक्सीडेशन रिडक्शन के हवाले से
नहीं सर, लाइक ओवरऑल ऑर्गेनिक, लाइक उसके अंदर लाइक चेक कर ले आप.
नहीं, वो तो रहता है. अभी तो मैंने खाली ये वाला पार्ट किया है. किधर है? अभी तो मैंने रीडॉक्स किया है. क्लियर है? अभी हमने 3 पार्ट्स किए ना, ये हमारे 3 पार्ट्स है ना, हम पार्ट 3 पे है ना. पहले पार्ट में हमने इलेक्ट्रोफिलिक सब्स्टिट्यूशन पढ़ी थी, सारों की पढ़ी थी. वो पहला पार्ट पता नहीं कहाँ चला गया, नीचे होगा कहीं. फिर सेकंड पार्ट में वी डिड एसिड बेसिस, और फिर थर्ड पार्ट में वी डिड रीडॉक्स. ठीक है, इज दैट क्लियर?
यस सर.
तो अब हम स्टार्ट करें पार्ट नंबर 4. मैं दूसरा बोर्ड निकाल रहा हूँ. ठीक है, अच्छा नाउ वी स्टार्टिंग पार्ट 4. ये वो एंड पार्ट है कि इसके अंदर ना विल कवर ऑल द वो छोटे मोटे रिएक्शंस. तो मेन चीज वीव कवर्ड इट. ठीक है, वीव ग्रुप्ड थिंग्स टुगेदर. हाइड्रोलिसिस क्या था, कंपैरिजन वो भी किया था आई गेस.
सर आई गेस आपने एसिड हाइड्रोलिसिस की थी.
नहीं, एसिड हाइड्रोलिसिस नहीं. हमने पार्ट 1 जो था ना, वो तो सारा इलेक्ट्रोफिलिक सब्स्टिट्यूशन था. ठीक है, दिस वाज पार्ट 1 के नीचे होगा. हाँ, ये वाज पार्ट 1. ठीक है, ये सारा वो था. पार्ट 2 जो था ना, कहाँ गया पार्ट 2, इसको खोल लेते हैं. अच्छा, जो पार्ट 2 था ना, उसके अंदर वी डिड 2 थिंग्स. वो मैं इधर ऐड भी कर देता हूँ ताकि वो, हाँ, एक था हाइड्रोलिसिस ऑफ Cl रिलेटेड कंपाउंड्स, और फिर हमने किया था वो एडिशन एलिमिनेशन मैकेनिज्म भी था. फिर हमने वी डिड द स्ट्रेंथ ऑफ एसिड्स एंड बेसिस, राइट. तो ये मैं इसके ऊपर ना हेडिंग भी दे देता हूँ. जस्ट 1 सेकेंड. बोर्ड के टाइटल में ये वाला जो है, दिस इज हाइड्रोलिसिस, एसिड्स, बेसिस, comparisons, ठीक है. अच्छा, अब ये पार्ट 4 जो बच गया ना, रह गया, दैट्स पार्ट 4, ठीक है. दैट्स ऑल द लेफ्ट ओवर स्टफ. तो उसमें आई गेस पॉलिमराइजेशन एक्सेट्रा वो सब चीजें भी ना आ जाएंगी, ठीक है. पॉलिमराइजेशन, you don't have many things that are new in polymerization, लेकिन let's so इसका एक से मैं टाइटल रख लूं. चलिए पार्ट 4, 1 सेकेंड. अच्छा, पार्ट 4, उसके अंदर जो इम्पोर्टेंट चीज है ना, वन थिंग इज दैट there's a thing called diastaph and azodize, ठीक है. That's very important, ठीक है. This is also known as, अच्छा, also known as azodize. अच्छा, so one thing is कि ये वाला part, diastaph and azodize, it's a simple reaction but kind of really important. First thing is, अच्छा, remember chemistry जो है ना, that's like almost everywhere, that's around you, ठीक है. One very important chemical is paints, ठीक है. I mean, we take some things for granted, but some things are like really, really important. So paints जो है ना, paints, dyes, etc., that's like one of the most important chemicals that's around you, ठीक है. क्योंकि if you just notice everything around you, that's kind of painted, it's got dyes in it, ठीक है. Everything from your clothes to your cars to everything around you has paint on it, ठीक है. तो हम पेंट को बड़ा लाइट ले लेते हैं, लेकिन पेंट इज लाइक वन ऑफ द मोस्ट इंपॉर्टेंट केमिकल्स ऑन दिस प्लैनेट, ठीक है. एटलीस्ट फॉर अस. तो मतलब मेकअप से लेके ना हर चीज में दिस पेंट, दिस डाइज इन इट, ठीक है. So so paints are really important. Now the most important thing about paints is that they need to be really stable, ठीक है. So they need to be really stable. Why do they need to be really stable? के stable इस तरह के, if I have a white colored, a yellow colored car, तो एक महीने बाद ना धूप में अगर वो पड़ी हुई है ना, तो इट्स कलर डज नॉट चेंज, ठीक है. द पेंट हैज टू बी रियली रियली टफ, ठीक है. इफ आई पेंट अ हाउस, आई वांट इट टू बी, क्या कहते हैं, आई वांट इट टू मेंटेन इट्स कलर, ठीक है. सिमिलरली कोई अगर नेल पॉलिश लगाता है ना, वो पानी से धोता है, तो पता लगे नेल पॉलिश का कलर ही चेंज हो गया, ठीक है. सो यू डोंट, सो पेंट्स हैव टू बी एक्सट्रीमली स्टेबल, ठीक है. सो दे हैव टू बी एक्सट्रीमली स्टेबल. Azodize are one such dyes that are very, very stable. They don't decompose, they don't react, they're very inert, ठीक है. So they are very, very stable. So this is just one simple way of making azodize, ठीक है. How are azodize made? First thing is कि an azodize is made for, अगर मैं बिल्कुल start से start करूँ ना, तो it starts off with a benzene, ठीक है. If you start off with a benzene, so you can get these aromatic compounds from different places, ठीक है. Naturally be from oil as well, ठीक है. So you start off with benzene, then the next thing you do is you nitrate it, ठीक है. So when you do nitration of benzene, firstly, how do you do nitration of benzene? कि you NO2 attach करना है, so you add concentrated nitric acid and you add concentrated sulfuric acid, और फिर उसके अंदर you would also add the conditions which are temperatures 55 degree. ये पहला रिएक्शन हमने किया था, इलेक्ट्रोफिलिक सब्स्टिट्यूशन, राइट, ठीक है. We did all of this, we did the mechanism as well for this.
सर
हाँ जी.
सर ये जो हमारे पास लाइक आपने जो एसिड हाइड्रोलिसिस की और बाद में उसके बाद बेसिस जो आए थे, सर ये उससे कम्प्लीटली डिफरेंट है ना? ये
कैसे?
मतलब अलग से टॉपिक स्टार्ट है ना?
हाँ, ये उससे अलग है। वो तो सारा हमने वो किया था ना, रिडक्शन और ऑक्सीडेशन अभी कर रहे थे ना। इसका अब उससे कोई ताल्लुक नहीं है। और रिमेम्बर, मैं ऑर्डर में नहीं जा रहा, ठीक है? मैं वो उन चीजों को इकट्ठा पढ़ा रहा हूँ जो सारी इंटरलिंक्ड है। तो वी डिड ऑल ऑफ redox, मतलब जितना भी redox reactions थे ना, वी डिड ऑल ऑफ इट ऑन वन पेज. We did all the electrophilic substitution reactions in one go, ठीक है? अच्छा, so this one, NO2 gets attached to it. अच्छा, what do you do after that? What you do is you reduce the NO2 and you turn it into, अच्छा, you turn it into, किसका अभी अभी हमने पढ़ा था 10 plus concentrated HCl, right? अच्छा, 10 plus, अच्छा 10 plus concentrated HCl, ठीक है? You, and this nitrobenzene turns into NH2. तो यहाँ पे ना you get NH2 instead now. अच्छा, now when you turn it into NH2, now the real story starts, ठीक है? कि you got a phenylamine. I mean, you got a nitrobenzene, then you got a, लिख भी देता हूँ. अच्छा, you got a nitrobenzene, then you had a phenylamine, और फिर यहाँ पे ये पहला तो बेंजीन था, ठीक है? अच्छा, then this phenylamine gets converted into different things, ठीक है? So it gets converted into a diazonium ion. So what's going to happen after this is you reacted with NaNO2 plus HCl, ठीक है? This is also sometimes referred to as HNO2 क्योंकि दोनों मिलकर ना they end up forming HNO2. So sometimes in the market scheme they write HNO2 as well. So NO2 and HCl are mixed together and the temperature has to be kept really low, below 10 degrees centigrade. And this particular phenylamine gets converted into an ion that's called a diazonium ion. ठीक है? So what happens to it is कि जो H है ना, it forms a very unstable diazonium ion. It looks like this. ठीक है? So it ends up forming a very unstable diazonium ion. So a lot of times, so this particular ion is written in many different ways. A lot of times they have this Cl as well as attached to it. It's a plus one, so there's a क्योंकि वो HCl है, तो there's going to be a Cl minus one attached to it as well. Short form में अगर लिखा हुआ है, so they might write it as C6H5 and N2 plus and Cl minus one. ठीक है? So condensed form. So that's known as your diazonium ion, extremely unstable. And it decomposes if you increase temperature. तो ये decompose करके ना it ends up forming a phenol. तो यहाँ पे हम लिख देते हैं कि it decomposes very quickly. So decomposes if temperature becomes greater than 10 degrees centigrade, you warm it. And water present hydrolyze कर जाता है, decompose क्या करता है, hydrolysis होता है इसका, ठीक है? ठीक है? तो as soon as if there's water present, it's going to react with water. but the condition is that the temperature has to be greater than 10. So ये जो iron है ना, that actually decomposes and ends up forming a phenol. So the N triple bond N plus 1 goes away, and in its place you are left with an OH. और वो जो N है ना, they end up forming NH4 plus 1 ammonium ions. ठीक है, they end up forming ammonium ions. अच्छा, ये scheme है अभी. This is not the formation of the di as such right now. ठीक है, this is just the formation of the diazonium ion, which is this one. तो benzene से NO2 बनाओ, nitrobenzene बनाओ, nitrobenzene reduce it NH2, and then you form the diazonium ion, which is extremely unstable. Okay, it's extremely unstable. So the temperature has to be kept below 10. Now the good thing about this diazonium ion is that it's an electrophile. Okay, so this molecule that's produced, it's a positive ion. Positive ions, they get attracted to negative ions or negative things. So that's an electrophile. So the next thing that happens is कि वो जो azodiaze formation है ना, with the cover ही कर लेते हैं. So the azodiaze formation. So the electrophile, the diazonium ion electrophile, it attacks a benzene. It attacks, or it's attracted to an activated benzene. ठीक है, activated benzene का मतलब है कि benzene with OH or NH2. Or we can say any electron donating group. अच्छा, तो situation ये होगी. ठीक है, let me explain this, that here's your diazonium ion, ठीक है, which has a positive charge. अच्छा, और यहाँ पे ना there's this other benzene that's that's a phenol. और activated benzene, ठीक है, ये बस last part है कि let's say there's an OH benzene, a phenol. So why is it activated? Because ये जो O के lone pairs होते हैं ना, they overlap with these lone pairs, they overlap with benzene's electron cloud. And the electron density, it increases at positions 2, 4, and 6. हमने पहले पढ़ा था कि the electron density increases. And all the other electrons, they get repelled, so the electron density also increases on the extreme other end as well. So इन दोनों के बीच में reaction होगा. So phenol comes along. The N triple bond N plus 1 is very strongly attracted to the electrons, the electrons in benzene. And your final product is going to look like this. ये आपका molecule है, and the final product is going to look like this, that these two would simply join up. Okay, the positive ion, one bond will be less. The phenol is going to come in, and the N is going to be attracted to that benzene. It's going to join up with that benzene. ठीक है, तो वो बेंजीन के साथ जुड़ गए, एंड दैट्स योर azodide, दैट्स योर azo ग्रुप. ठीक है, this thing over here, that's your azo group. An N double bond N linking two benzenes together. Stable वो इसलिए होता है कि इसका भी pi bond जो होता है ना, that overlaps with benzene, so there's this huge network of pi bonds, so it's a very stable molecule, and the good thing is it's colored as well. ठीक है, so that's your reaction. The only thing that you require for this reaction is that the temperature has to be kept below 10 degrees centigrade, वरना वो decompose कर जाएगा, because the diazoxamine is very unstable, and you need NaOH aqueous alkaline conditions for this reaction to happen. So that's it. Okay, that's how an azo dye is going to be formed.
सर
हाँ जी.
सर आप मुझे एक्सप्लेन कर सकते हैं सर, यहाँ पे इस वजह से कनेक्शन का इशू आ रहा है.
अच्छा एक सेकंड. एक सेकंड. अच्छा ये मैं फिर से पूरा एक्सप्लेन कर रहा हूँ. ठीक है, ये first part ना, that's benzene, nitrobenzene. ठीक है, we did that reduction 10 plus NH2. It, और ये वाला part, that's NNO2 plus HCl, temperature should be less than 10. It ends up forming this very unstable diazonamine. ठीक है, अगर टेम्परेचर जरा सा भी बड़ा ना इंक्रीज हुआ, तो दैट विल decompose and it will form a phenol. It will react with water, so we don't want that to happen. So the diazoniamine is going to react with a very activated benzene. It's going to react with a phenol or a phenylamine. So when it does that, so the positive charge will be attracted to the high charge density electrons over here, and it's going to join up. तो ये आपकी ना वो colored dye है. That's your colored dye. बात समझ आइए?
यस
बस ये बाकी बाद में कल एक्सप्लेन कर देता हूँ. ये वाला जो मैंने लिखा
सर.
है ना,
इसका कलर क्या है?
हाँ,
इसका कलर क्या है?
मतलब डिफरेंट कलर्स हैं, वो सारे मैं दिखा देता हूँ कि एजोडाइज अगर ना, हर एजोडाइ में ना, इट्स नॉट एग्जैक्टली दिस स्ट्रक्चर. ठीक है, अच्छा फर्स्ट थिंग रिमेंबर दे यूज्ड एवरीवेयर. अब इसका ये जैसे यहाँ पे कलर्स लिखे हुए ना, ठीक है, तब ये देखो ये. अच्छा कलर चेंज किस तरह होगा? अगर बेंजीन के साथ ना डिफरेंट ग्रुप्स अटैच्ड होंगे. फॉर एग्जांपल दिस वन, ये दिस इज, ये मेरे ख्याल से उसके कलर्स हैं सारे वही हैं. बेंजीन, एन डबल बॉन्ड एन बेंजीन, राइट. वन ऑफ देम इज एक्टिवेटेड, द अदर वन इज, उसके साथ पे डिफरेंट चीजें अटैच कर लो तो दैट विल, बट बेसिक स्ट्रक्चर इज द सेम. एन डबल बॉन्ड एन बेंजीन बेंजीन. यहाँ पे भी इट्स गोइंग टू बी द सेम थिंग. यू सी एन एन डबल बॉन्ड एन एंड देयर इज अ बेंजीन एंड अ बेंजीन ऑन द अदर साइड. ठीक है, तो कॉम्प्लिकेटेड एजोडाइज होती हैं, तो वो आप जितना बड़ा मॉलिक्यूल कर लो, बट द बेसिक स्ट्रक्चर काइंड ऑफ रिमेन्स द सेम. इट्स वन बेंजीन एंड वन बेंजीन which are tied up together with a n double bond n. ठीक है, क्लियर है बात?
यस सर.
तो चलो ये बाकी कल पे कंटिन्यू करते हैं. ठीक है,
ओके सर.
चले, ओके, ठीक है.